past couple of days, we have been working on arithmetic sequences. An arithmetic sequence went up or down by the same amount every time. I do not have an arithmetic sequence going on right here today. I went from 1 to 2. Sorry, that went up by 1. I went from 2 to 4. That went up by 2. This goes up by 4, and etc. Could you tell me what's going on? Like, how could I get to the next number? Like, what was I doing in this sequence? I was just like multiplying by 2, right? Instead of like adding a common difference, today it's multiplication, right? It's just multiplying. And that's called the geometric sequence. We got 3 concepts today, though. One of them is a geometric sequence. So here's a little formula. Please, this is a practice sheet. You don't want to lose. This will help you out greatly on the quizzes, right? So it's got this weird little formula. The only difference is they stopped doing like the a sub n's and the a sub 1's. They started putting g sub n's and g sub 1's. I like that because it's for geometric, right? You know, they don't always use those letters, though. So the weird thing is we need this little r value right here. R stands for the constant ratio right here. So right here, here's literally some homework questions. They gave me a geometric sequence, and they say find r. R is the number in the parentheses. So what do you feel on this guy? What is the constant ratio? -3. That means that they're just multiplying by -3 every time, right? In my one back here, the constant ratio was 2 because I was multiplying by 2 every time. Here, if they wrote out a sequence, they're going to multiply by -3. So what does this say? Find g of 2. All that means is we put 2 in for n. So grab ye old calculator. And I'll tell you what, I think we are all smart enough to figure one little thing out first. You see how I've got to put 2 in for n? It's up in the exponent, but there's a darn -1 after it. Do you think you could mentally figure out what 2 minus 1 is before you punch it in? What's 2 minus 1? It's just 1. So you're just punching in 2 times -3 to the first power in that case, which I got -6. You have to do a little bit of subtraction to figure out that exponent. So if I want to put 7 in for n, guess what the exponent's going to be? It's 7 minus 1, which is how much? 6. We're just going to the 6th power. So I'm just literally typing what I see, 2 times -3 to the 6th power, because they wanted me to find the 7th term on that guy. So I got 1458, baby. That's a big boy. And then find the first term in that sequence. So 2 times -3. You see how I'm using parentheses too? That will keep you safe to where if you don't, like, make sure you're putting it in parentheses. What would be the exponent on that? To what power? Because you got to subtract 1 on it. Again, it's 1. 1 minus 1 is 0, right? And maybe you were trained way back in the day, anything raised to the 0th power is 1. And I took 2 times that, so 2. Here's another little secret. This is your first term right here. The number in front of the parentheses is your first term. So if you don't want to punch that in, you can just kind of check that out. So that's one thing. They ask you to find the ratio in a certain amount of terms. Another thing they ask you to do is they give you the sequence and they want you to find the ratio. Here's how to do it. Let's put this note because next week you'll want to look back and go, how the heck did we find that again? Here's how we'll find it. Divide second term by first term. Please write that down because I don't want to be your quiz guy and be like, sorry, I can't tell you how to find that R because I told you to write that down. Divide second term by first term. That's all you got to do. To find the ratio, we're going to divide second term by first term. So, who's the second term? 3. Divided by the first term, 2. What's our constant ratio? 1.5. So, we found that by dividing the second term minus the first term. Now, let's see if we can write this. G sub n. This is the explicit formula. That's what a lot of people asked last time on homework. They're like, what do they want me to do here? When they say write the explicit formula, we're going to do this. We're going to just rock and roll this. We're going to put this dude in. I need G sub 1. Who is the first term in that sequence? You got to go into here and look him up. Who's the first term? 2. Thank you. Then we'll put parentheses. What goes inside of there is R. We just figured R out. R is right here, so we down with 1.5 goes right there. And then what's weird is we just got to raise it to the n minus 1 power. That's all you need to write the explicit formula for a geometric. You need to know the first term, that was 2, and we needed to know the ratio. We found that by the second term divided by the first term. It's like if you can do the fourth term divided by the third term, it'll give you the same thing because they're always multiplying by 1.5. But to me, it's like just take the second dude divided by the first dude. So could you do that here? Could you find the constant ratio? It's very likely it is a decimal. You know what I mean? It's very normal for it to be a decimal. So take the second term divided by the first term. Second term is 16. First term is 20. Is that right? I covered it up. Is that right? Yep. I got 0.8. Is that cool with you? Like where I got that from, right? So second term divided by first term. See if you can write the explicit formula. You just use this dude right here. They got the g sub n taken care of you. You just need the first term, and then in parentheses, the ratio raised to the n minus 1 power. And then later, if they ask you to find like the 99th term in that sequence, you put 99 in for n, but would you believe like you would actually raise it to the 98th power because you got to do the 99 minus 1. Rock on? Cool. Looks good, all right? Geometric growth. Still the same thing. I just kind of like have this formula here. A population grows according to an exponential growth model. If the initial population is 17, like you see how they changed it from G's to P's now, so watch the letters that they use. So they said P sub 0. I'm sorry that this highlighter is not being selected. There we go. P sub 0 equals 17, so that's like the initial population. The common ratio is 1.25. It says find the following. The first term, the second term, the ninth term, and then here's like P sub n. That's the explicit formula. I think, like, well, I guess we need the first term first, right? So here's what I got to do. I just need to take this 0th term right here, which is 17, and take it times the ratio. Did they say it was 1.25? All right, so take it times the ratio. So 17 times 1.25. And the first term is 21.25. The reason why I had to find that is because the formula needs that. You don't start with the 0th term this time. That was the other formula from last time. We needed the first term. Now, let's write the generic explicit formula. I'll let you try that. 21.25 times 1.25 to the n minus 1. You see how I put the first term right in front of the parentheses? I put the ratio in the parentheses, and then I raised it to the n minus 1. I'll let you guys punch these in your calculator. To find the second term, you put 2 in for n. And to find the ninth term, you put 9 in for n. We did a little secret last time by just like subtracting 1 from it. So punch those bad boys in. Let's see what we get. They'll be decimally, right? They'll be decimally again. So to find the second term, I got to raise that to the first power because I got to do 2 minus 1. And I got a big old long decimal. We'll write that whole thing out. Read your homework to see if they want that rounded a certain way. But I'm going to write the whole thing out. If they wanted that rounded to 1 decimal place, that'd be 26.6. And then to find the ninth term, I'm going to take 21.25 times 1.25. What power should I raise it to if they want me to find the ninth term? Raise it to the 8th, right? Raise it to the 8th. And we'll round that to 1 decimal place. Do you want to do 126.6 or 126.7? 0.7, yep. That was concept number 1 today, like geometric sequence. Concept number 2, exponential growth. This is the formula that I want to use. Like, I just don't like this one. They put it in like this weird format. They mean the same thing. So when do you use it? 1, when it says they grow exponentially, or 2, when a quantity grows, it's got to grow, mean increase by a percent. So check it out. If we read number 5 right here, between 07 and 08 in Olympia, Washington, a population, boom, grew almost 3%, right? If it grows by a percent, we're going to use this formula, of a population to 245,000 people. Write an exponential growth formula for this situation. Here's what we got to do. We've just got to put A equals this original p-value, right? This original p-value of 245,000, 245,000 times 1 plus our rate. What we need is to change this percent to a decimal. Just give me a second. So what is 3% as a decimal, y'all? 0.3 or 0.03? Yeah, watch that. You got to move it 2 spots, right? And then you see we put that in here. You're never allowed to put a percent into a formula. You have to change it to a decimal first. But they want us to add 1 to it. So it's going to be 1.03. 1.03. Because it's going to grow, it's always got to be bigger than 1 in that situation. Okay? So could you do this? Could you put in what the population would be in 2014? We have to figure one thing out first. This thing started in like 08, right? So how many years has it been from 2014 to 2008? 2014 to 2008, how many years has that been? 6. So put 6 in for n in that situation, okay? 245,000 times 1.03 to the 6th power is what we're doing. It's been 6 years later. What's our population? This big bad boy. They're going to make you round it. This is people, so we'll round to whole numbers. Does that kind of make sense? So what do you think? Round it up to 3 or keep it at 2? 92,543, right? So I'll let you write all that down, okay? So we start with the OG population of 2050. It's growing by 5.4%, so like that becomes 0.054 as a decimal. You always move it 2 places to the left, so like 0.054, but I got to add 1 to it, so 1.054 to the nth power. And then they say, what would that be in 3 years? We'll just put a 3 in for that, times 1.054 to the 3rd. Using parentheses is just a safe method to making sure that everything works out according to the order of operations. So we'll round that to the nearest bird. In this case, I would call that 2,400 birds in that guy. Right? So I got 2,400 birds. There's definitely some questions like that on homework where you got to round to the nearest whole number because they're talking about people, they're talking about birds, or something like that. So they will be decimally. We'll round them how they tell us to round them. Rock on? So that's exponential growth. How did you know it was doing it? Grew by 8%. The last concept of the day is exponential decay. It's real simple. It decreases by 8%, which is very, very common in our world. The point of this class is to talk real life. Here's one of the most real life situations. Have you ever heard of inflation before? You know, inflation is one of those things where the value of our money will not be the same down the road. Would you agree in the 1950s having $100 was a huge amount of money, and in 2024 having $100 is not that much money? I mean, it's not chump change either. Like if I handed you $100, you'd probably be pretty happy about it, but still $100 back in 1950 is way more than what it is today, or it was way more than what it was today. So that's called inflation. So suppose inflation decreases the value of money about 3% each year. And that's pretty close to real. You know, it's usually like 2.7, 2.8, 2.9, sometimes even 3.3. It's pretty darn close if you average out to be 3% each year. In other words, if you have $1 this year, next year it'll only buy you 97 cents worth of stuff. How much would $5,000 buy you in 15 years? Here's what we'll do. We will do the same formula right here. The only difference in it is it's not a plus, it's a minus in that formula. So we're going to do the amount equals, how much did we start with? $5,000. And then if you want to write this out, you're welcome to. It's 1 minus 0.03 inside the parentheses. Where did I get the 0.03 from? The 3%. But some people are like, can I just call that 0.97? You know, like if it loses 3%, if I do 1 minus 0.03, you're going to get 0.97. So if you can mentally figure that out, good for you, right? It's the same thing in the parentheses. Raised to the 15th power. Where did the 15 come from? 15 years. So how much would $5,000 be worth in 15 years if inflation was 3%? We punch it in like this, 5,000. You're totally welcome to do 1 minus 0.03 in parentheses instead of typing the 0.97. It totally works, right? Raised to the 15th power. And that 5,000 bucks, since this is money, we'll go 2 decimal places on that. So that'd be $3,166.26. 26 cents, because I have to look at this third decimal. Because I want to round to 2 decimal places, I want to look at the third guy and see that he's 5 or larger, so that rounds him up to 26 cents. Cool? So $5,000 now would buy you $3,100 worth of stuff, basically, in 15 years. So what if that inflation was 2.95% each year? Let's do that same thing, man. Let's do the amount equals $3,500. 1 minus, I would love for you to change this percent into a decimal for me and put him in that spot. Move him 2 places to the left. Check it with mine. And then I'm going to put a 10 up there. My question is, do you understand why I'm putting the where I'm putting the 10 at, like where that came from, where this $3,500 came from, because that's how much we started with in this situation, and then moving the decimal. So $3,500 times 1 minus 0.0295 to the 10th, baby. And that would get us about $2,594, and what do you think? 31 cents or 32 cents? 32 cents. The last thing of the day is just like exponential growth or exponential decay. And I'm going to go way back to like 2011. Remember the Meghan Trainor song, It's All About That Bass, All About That Bass, All About That Bass? I know that's a long time ago. It's all about this number right here. This is the base right here. If it's even exponential, how do you know it's an exponential equation? The exponent has to be a variable. So on number 9, is the exponent a variable? Yes or no? Yes. Is this base bigger than 1? Yes, that's exponential growth. If the base is bigger than 1, it's going to grow. But there's 2 questions you got to ask yourself, bro. First, is it even exponential? Is there a letter up as an exponent? I don't care if it's an X or an N or whatever. Is there a letter, right? Yes. Is the base bigger than 1? No. That's exponential decay. Exponential decay. And here's the wacky boy. They try to trick you. You see there is an exponent, but it is a 3, right? It is not a letter. That is neither. That is just a different type of graph. To be an exponential graph, the variable is an exponent. So this guy right here, is it exponential? Is the exponent a letter? Yes. Is 5/4 bigger than 1? For those who don't know, you could always punch it in and see if 5/4 is bigger than 1, and you get 1.25 back. So what do you think, exponential growth or exponential decay? Growth. And then to tell by looking at the graphs, what do you think about this graph? It's definitely exponential. As you read it from left to right, is it going up or is it going down? It's going up. That's exponential growth. And this guy right here is going down. That's exponential decay. Cool? Thank you.